Hello guys, my name is Shreyas. I'm an educator at an academy. You can follow me on the Learning app as well. You can follow my set of courses on the Learning app as well. So this is a lesson about the nuclear reactors. So please do rate it, review it and share it. And please do subscribe us on our YouTube channel, that is the Unacademy Engineering Curriculum channel. Thank you. So guys, let's continue with our course, Elements of Mechanical Engineering. So I have given my introduction already. My name is Shreyas. I'm a BE Mechanical Engineering student. You can find me at the URL present here, which is my Unacademy user platform. So nuclear power is the course we'll be dealing with all the lessons today. So the target audience for this slide will be engineering students, general audience who are interested in science related courses, people who are interested in natural resources, people who are interested in knowing the involvement of environmental resources. So the learning outcomes for this slide will be, you guys will come to know about the nuclear power plant. You guys will come to know the history of nuclear power plant. You guys will know in detail about the nuclear reactors and basically two types of reactors in today's class, that is the pressurized water reactors and the boiling water reactors. So nuclear reactors, let's start with our lesson. So before moving on to the lesson, let me have a quote. So to every action there is always an opposite reaction or an opposed reaction. So you guys must be very motivated or very fueled. So because there are if there is a victory, there is also a defeat in your problem. So always you should be like self-confident. So nuclear power plants, let's start with the lesson. So it is a generating station in which nuclear energy is converted into electrical energy. It is also called as the thermal power station. Heat source is actually a nuclear reactor and it is considered to be one of the base load stations. So this is a nuclear power reactor. You can see over here, this is a nuclear power plant. Sorry for that. So the history of nuclear power plants are, the first electricity production was done on the date 20th December 1951 in USA. The first commercial usage of the nuclear power plant was happened on the date June 26th, 1954 at Obninsk, Russia. The first full-scale power station was stationed at the Kandahar, UK, Britain. The present scenario of this nuclear power plant is, there are around 442 nuclear power plants in 31 countries which produce electricity, and under construction there are around 66 power plants with a capacity of around 65 gigawatts in 16 countries. So you can see here the Kandahar power plant, which was actually the first power plant to be produced or to be set up. So this was the building stages of the Kandahar power plant. So the importance of a power plant, it is actually rapidly increasing with the electricity demand. So there is need of huge amount of electrical energy, and we also require an alternative fuel. The nuclear energy is more efficient compared to other energies, and more energy can be extracted from a little amount of nuclear energy. So nuclear reactors, let's start with this. They are also known as atomic piles. It is a device used to initiate and control a sustained control chain reaction. It is used at nuclear power plants for electricity generation. Heat from fission reaction is passed to a working fluid which runs through steam turbines. It derives a ship propeller or turns an electrical generator. It is used to produce isotopes for medical and industrial use. So this is how a nuclear reactor is shown for you guys. So this is actually a nuclear power plant. So this is actually the nuclear reactor where the actual reaction or where the fuel production actually happens. So you can see the inside of a nuclear reactor here. You can see the fuel assembly. So how it is actually kept. So you can see here, the nuclear reactors are not always placed next to each other. There is relatively a distance amongst them while placing the nuclear reactors. So you can see the types of the nuclear reactors, in which the boiling water reactor, the pressurized water reactor, the steam generating heavy water reactor, the fusion reactor, and the high temperature graphite moderated reactor, the HTGR reactors, will be studying in detail in our courses in our next set of lessons. So pressurized water reactor, let's start with it. The excellent properties of a water as a moderator and a coolant make it a natural choice for the power reactors, and the pressurized water reactor has been extensively developed in the USA. The most important limitation on a pressurized water reactor is the critical temperature of water, that is 374 degrees centigrade. This is the maximal possible temperature of the coolant in the reactor, and in practice it is considerably less, possibly about 300 degrees centigrade to allow a margin of safety. In a pressurized water reactor, the coolant pressure must be greater than that of the saturation pressure. That is, it should be more than 300 degrees centigrade to suppress boiling, and the pressure is maintained at about 155 bar so as to prevent bulk boiling. A PWR power plant or the pressurized water reactor power plant is composed of two loops in series, the coolant loop called the primary loop and the water stream or the working fluid loop. The coolant loop picks up the heat in the reactor and transfers it to the working fluid in the steam generator. The steam is then used in a Rankine type cycle to produce electricity. So this is a pressurized water reactor. You can see here how the control rods and the reactor are placed, and how it is actually the pressurizer is used in other than the condenser or the generator which is used. Here the pressurizer is used in case of the condenser. So you can see these small compartments, they are nothing but the coolants, and this is actually the coolant pipe which is supplied to the reactor. So let's continue with it. The fuel in the pressurized water reactors is slightly enriched uranium in the form of thin rods or plates. The cladding is either of stainless steel or zircaloy. Because of very high coolant pressure, the steel pressure vessel containing the core must be 20 to 25 centimeter thick. A typical pressurized water reactor contains about 200 fuel assemblies, and each assembly being an array of rods. In a typical fuel assembly, there are 264 fuel rods and 24 guide tubes for control rods. The grid spacers maintain a separation between the fuel rods to prevent excessive vibration and allow some axial thermal expansion. So this is uranium, the fuel which is being used in the pressurized water reactors. So let's move on to the another type of water reactor or the nuclear reactor, namely the boiling water reactor. A boiling water reactor, it differs from the pressurized water reactor in that the steam flowing to the turbine is produced directly in the reactor core. The steam is separated here and dried by mechanical devices located in the upper part of the pressure vessel assembly. The dried steam is sent directly to the high pressure turbine, thus eliminating the need for steam generators. The coolant, it thus serves as a triple function. The function is that of a coolant, moderator, and that of a working fluid. Since the coolant boils in the reactor itself, its pressure is much less than that of a pressurized water reactor and is maintained at about 70 bar of pressure and at around 285 degrees centigrade. However, an increase in the boiling rate displaces the water or moderator in the core and reduces the ability of the moderator to thermalize neutrons and hence reduces the reactor power level. So you can see the boiler water reactor over here. So this is where the core will be kept, and the containment or even the structural modifications of the reactor is very different compared to that of a pressurizer. You can see there is no pressurizer over here. Instead of that, there is a turbine generator and there is a demineralizer for the process of boiling of the water. So the power levels are kept above 60% in this boiler boiling water reactors. The saturated liquid, it separates from the vapor at the top of the reactor in a steam separator which flows downward either internally with the reactor or externally outside the reactor and mixes with the return condensate. This circulating coolant again flows naturally due to density difference or by a forced circulation pump. The ratio of the recirculated coolant to the saturated vapor produced is called the circulation ratio, and the boiling water reactor core exit quality varies from 10 to 14%, so that the circulation ratio is in the range of 6 to 10. This is very necessary to avoid large void fractions in the core, which would reduce the moderating power of the coolant, resulting in low heat transfer coefficient, also the vapor blanketing and burnout. So thank you guys. Any questions? Please drop those in the comments box below. You can find me at my Unacademy user platform in the above URL. And if you have liked the presentation, please do rate this course and review this course. And please do recommend this lesson or slide. And you can follow me again on my Unacademy user platform for my another set of courses. So thank you guys. Have a wonderful day. Thanks.